MRP Gajwel. So in this class I am going to discuss about the state, the frame and field frequencies and need for horizontal and vertical synchronization and blanking pulses. Mention the important standards of TV transmissions as per CCIR. List different types of scanning and distinguish between progressive and interlaced scanning. So first of all we will discuss about the definitions of frame frequency and field frequencies. So first one is frame frequency. So actually the frame is nothing but one complete image in a video system is called as a frame. One complete image in a video system is called as a frame. So frame rate also known as frame frequency. Here the frame rate is called as a frame frequency. It is the frequency at which an imaging device displays the consecutive images called as a frames. So in video systems, pictures or images are displayed as a frames. That is nothing but images will be displayed as a frames. So the number of frames scanned per second is known as a frame frequency. Okay. So here, so first of all, frame is nothing but one complete image in a video system is called as a frame, or in video system the pictures or images are displayed as a frames and the number of frames scanned per second is known as a frame frequency. Frame frequency is nothing but a number of frames scanned per second is known as a frame frequency. The frame frequency is also known as frame rate or picture frequency. Here the frame frequency is also known as frame rate or picture frequency. Okay. So the frame rate for a motion picture, that is nothing but a cinema. So cinema is a motion picture example. So in cinema or motion picture, the frame rate or frame frequency is 24 frames per second. Coming to the television, the frame frequency or frame rate is 25 frames per second in India. Coming to America, the frame rate for television is 30 frames per second in America. Okay. So frame and field frequencies. So here frame frequency is nothing but one complete image in a video system is called as a frame. Okay. So in each and every video system, pictures or images are displayed as a frames. So here the number of frames scanned per second is known as a frame frequency. Okay. This frame frequency is also called as frame rate or picture rate. Okay. So the frame rate for a motion picture, that is in cinemas, it is a 24 frames per second. Coming to the frame rate for a television is 25 frames per second in India. Okay, the frame rate for television is 30 frames per second in America. Okay. So next one is a field frequency. So in interlaced scanning, the entire frame is divided into two fields. So actually we have two types of scannings are there, interlaced scanning and progressive scanning. In case of interlaced scanning, the total frame is divided into two fields, that is even field and odd field. So here the fields are scanned sequentially. Okay. So the number of fields transmitted per second in television is known as a field frequency. So here field is nothing but here the total entire frame is divided into two fields. One is even field, one more is odd field. So here the fields are scanned sequentially, means line by line the fields will be scanned. So here the number of fields transmitted per second in television is known as a field frequency. So here the field frequency in the 625 line system is equals to 2 into frame frequency. In India, the television frequency is, in India, frame frequency for a television is 25. Here we are considering each and every, we have a two fields. Each and every frame consists of a two fields. So 2 into frame frequency. That is equals to 2 into 25. That is 50 fields per second. Okay. Next one is need for horizontal and vertical synchronization and blanking pulses. So here okay, need for horizontal and vertical synchronization and blanking pulses. Okay, so in that, so here the scanning will be done both at the transmitter side as well as receiver side. Okay, so actually the scanning process will be done both sides, that is at the transmitter side and receiver side. Okay, so here the scanning process is used to convert the, what is the function of scanning process? The scanning process is used to convert the picture information, that is an optical information, into video signal. Okay, that will be done at the transmitter side. Coming to the receiver side, okay, so after receiving the TV receiver, after receiving the video signal will be received by TV receiver and converted back into picture signal, that is in a form of optical signal on a screen by the same scanning process. Okay, so here the scanning process will be done at both sides. One is at the transmitter side, one more is at the receiver side. So coming to the transmitter side, the scanning process is used to convert the picture information into video signal, that is the optical information into electrical signal. Okay, that will be done at the transmitter side. Coming to the receiver side, the video signal is received by the receiver and converted back into picture, that means optical information on a screen by the same scanning process. Okay, so here the synchronization is the process by which the scanning of each line and each field should be started as well as finished simultaneously at transmitter and at receiver at the same instant. Otherwise, the picture details would split and get distorted. So, synchronization is nothing but a what here? Both transmitter and receiver side, the same process has to be done. So, at the transmitter side, whatever the signal that will be sent is exactly received by using the receiver. Okay. So, otherwise the picture details will be split and get distorted. Splitting and the total signal will be distorted. So, to ensure the perfect synchronization between the transmitter and receiver, so here both sides, both transmitter and receiver side, synchronization for exact synchronization purpose, we use H-sync and V-sync pulses are transmitted during the retrace period, that is the flyback intervals. Okay. So, to get a perfect synchronization between the transmitter and receiver side, we have to use horizontal and vertical synchronization pulses during the retracing period, that is at the flyback intervals. Okay. So, next, need for blanking pulses. So, here the movement of the electron beam from right to left of the raster is known as a retrace. That is nothing but a flyback. So, during the retrace period, the electron beam will be blank or invisible. So, here the blanking pulses are transmitted in order to cut or blank the electron beam during the retrace period. So, here during the retrace period, during the retracing period, the blanking pulses are transmitted in order to cut or blank the electron beam during the retrace period. So, that is the function of need of horizontal and vertical synchronizing pulses and blanking pulses. Okay. So, vertical and synchronizing pulses, why we use vertical and synchronizing pulses is for perfect synchronization purpose, we use horizontal and vertical synchronizing pulses. So, in case of horizontal synchronizing pulses, the pulse is needed at the end of each active line, and coming to the vertical synchronizing pulse, a vertical synchronizing pulse is required after each field is scanned. These are also known as H-sync or line synchronizing pulses, H-sync or line synchronizing pulses. The V synchronizing or vertical synchronizing pulses are known as V sync or field sync pulses. The duration of H sync pulse is 4.7 microsecond, and the coming to the duration of V sync pulse is 160 microseconds. Okay, next one is mention the important standards of TV transmission as per the CCIR. Okay, so here there are several standards adopted for TV broadcasting as said by CCIR. CCIR is nothing but a consultative committee on international radio. Consultative committee on international radio. Okay. So, actually we have several standards were adopted in the TV broadcasting, but here we use, in India we use CCIRB 625 line system. In USA use CCIRM standards, that is a 525 line system they used. In France, CCIRF standards, that is 819 line system used. So here we have to discuss about the CCIRB standards, that is a 625 line system for monochrome television that was adapted in India. Okay, so the characteristics were given below. So one see here the video characteristics. So here the number of lines per picture is, here we are using a 625 line system. So here the number of lines per picture is 625. Next, interlacing ratio 2:1. Coming to the field frequency, 50 fields per second. Picture frequency is 25 pictures per second. Line frequency or tolerance 15,625 lines. That is next, coming to the aspect ratio 4:3. Scanning sequence for lines is left to right. Scanning frequency for fields is top to bottom. For fields we use a vertical scanning. Here we use a horizontal scanning. Next, video bandwidth is 5 MHz and approximate gamma of the picture signal is 0.5. Coming to the horizontal scanning. In horizontal scanning, we use a H-sync or a line period, that is H is 64 microseconds. In that, active line period is 54 microseconds, that is a tracing period. Coming to the line blanking period or retrace period is 12 microseconds. And width of the horizontal blanking pulse, that is front porch width is 1.5 microseconds. Back porch width is 5.8 microseconds. Width of the H-sync pulse is 4.7 microseconds. Next, vertical scanning details. So here the width of vertical blanking is totally 1280 microseconds. So in that, pre-equalizing pulses is 160 microseconds and post-equalizing pulses is 960 microseconds and vertical blanking pulses 160 microseconds. Next, radio frequency characteristics. In that, channel bandwidth is 7 MHz. Sound carrier relative to picture carrier is 5.5 MHz. Type and polarity of the video is A5 type and AM generative modulation. Sync level as percentage is 100%. Peak white level as percentage of peak carrier is 10 to 12.5%. In sound modulation, type is F3 FM. Carrier deviation is 50 kHz at 100% modulation. Pre-emphasis is 50 microseconds. And the ratio of radiated powers of vision and sound is 5:1. Okay, so these are the standards of CCIRB standards in TV transmission in India. Okay. In India, we use 625 line system. In America or USA, we use 525 line system. In France, 81 line system is used. So, coming to the video characteristics, number of lines per picture is 625 lines. Interlaced ratio is 2:1. Field frequency is 50. Picture frequency is 25. Line frequency is 15, 625 lines. Aspect ratio is 4:3. Scanning sequence for lines is left to right. Scanning frequency for fields is top to bottom. Here it is a horizontal scanning. It is a vertical scanning. Video bandwidth is 5 MHz and approximate gamma of picture signal is 0.5. Coming to horizontal scanning details, it is a line period is 64 microseconds. In that, active line period is 52 microseconds and the retracing period is 12 microseconds, and that is divided into these parts. Width of front coach is 1.5, back coach is 5.8, H sync pulse is 4.7. In vertical scanning, in that vertical blanking is 20 Hz, that is 1280 microseconds. In that, pre-equalizing pulses is 160, post-equalizing pulses is 960, and vertical blanking pulse is 160 microseconds. Coming to the radio frequency characteristics, channel bandwidth is 7 MHz and sound carrier relative to picture carrier is 5.5 MHz. Type and polarity of the video signal is A5M negative modulation we use here. Sync level as percentage is 100%. Carrier is 10 to 12.5%. Coming to the sound modulation, we use F3 FM and carrier deviation is 50 kHz at 100% of modulation. Pre-emphasis is 50 microseconds. Next, different types of scannings. So actually, in scanning process is done in two ways. One is progressive scanning, one more is interlaced scanning. That is not interlaced is scanning as a progressive scanning. So first of all, progressive scanning. So here the lines are scanned sequentially from 1 to 625 is called as a progressive scanning. So here the progressive scanning is also called as a sequential scanning because in this it is a process similar to reading of written information on a page starting at the top left. That is same like we have discussed in horizontal scanning also, line by line we will read. So same process. So that is lines are scanned sequentially from 1 to 625 lines. So in this scanning, the electron beam will scan all the lines sequentially, that is from 1, 2, 3 up to 4, 5, 6, 7, 8 up to 623, 24, 25. Mali again starts from 1, 2, 3 ala continuous ka. Okay. So this is a progressive scanning. Here the electron beam will scans the lines one by one. So after completion of one, again it goes to second line, third, fourth, one by one line will be scanned. Okay, up to last line. So this is same like a horizontal scanning and retracing line. Okay, retracing period. So it is a vertical retrace. After completion of the 625 line, again goes to starting line. Okay, so here the electron beam is the progressive scanning, starts at the top left of the screen and scans the first line and then jumps back to the left at the start of the second line, scans the second line, jumps back to the third line, scans the third line and so on. Okay, so itla one by one each and every line ఇది scan చేస్తూ వస్తుంది. ఫస్ట్ లైన్ అయిపోయిన తర్వాత జంప్ టు సెకండ్ లైన్, ఆఫ్టర్ దట్ థర్డ్ లైన్. సో అట్లా కంటిన్యూస్ గా 625 లైన్స్ వరకు స్కాన్ చేస్తుంది. So as soon as the scanning of the frame is complete, the beam jumps back to the original starting point at the top left and starts scanning the second frame and as fourth. So first frame complete అయిపోయిన తర్వాత ఏమవుతుంది, again the cursor or electron beam goes to the first state. Okay, next frame లో ఫస్ట్ ప్లేస్ కి వెళ్ళిపోతుంది, అంటే టాప్ లెఫ్ట్ కి వెళ్ళిపోతుంది. వెళ్ళిపోయి అలా కంటిన్యూస్ గా మనకి స్కానింగ్ ప్రాసెస్ అనేది జరుగుతుంది. సో యాజ్ సూన్ యాజ్ you can see the beam scans all the lines progressively, hence the name of the system is called as a progressive scanning. So progressive, why we call it here, we call it as a progressive. Here the scanning process is done sequentially, that means progressively, one by one it is the process is going on. So because of that, here we call it as it is a progressive scanning. In the progressive scanning suffers from the disadvantage of flicker effect. Okay, so flicker is nothing but So the disadvantage of progressive scanning is flicker. Next one is a interlaced scanning. So here the interlaced scanning is a process of scanning every alternate line instead of every successive line. So in progressive scanning we scan each and every line we scan, but here we are scanning every alternate line, okay, instead of successive line, okay. So here one field contains all the odd lines of the image and other field contains the even lines of the image. So actually we use a 625 line system that is divided into two fields, that is a 312.5 lines. Each field consists of a 312.5 lines. In odd field the line numbers are 1, 3, 5, 7 and so on, and are scanned, and even lines are skipped at that time. In even field the lines are 2, 4, 6, 7, 6, 8, 10 and so on, that will be scanned. At that time odd lines will be skipped out. So here the two fields make up a complete television picture called as a frame, okay. So one see here, so this is the first field and it's a first scanning, okay. So here the lines starts here. First line will be starts here. Okay, 1. After that alternate line. Okay, second will be skipped. Alternate line. Third. Tarvata. So alternate lines are scanned in the first field. Okay, that means 1, 3, 5 ala. Okay. So tarvata remaining lines, that is 4, 6, 8 ala untai kada. So avi next time lo manaki scan outai. So first field here ends. Okay. After that second field will be starts. So remaining alternate lines are scanned in the second field. Okay. So here the total second field will be ends here. So this is about interlaced scanning. So coming to the advantages of interlaced scanning. So here the interlaced scanning has the following advantages as compared to progressive scanning. So here we will avoid the flicker effect and increasing the downward rate of the travel of the scanning electron beam, so that every alternate line gets scanned instead of every successive line. So here the flicker effect will be avoided by scanning the alternative line. So here we are scanning each and every alternative line, not a successive line. So మనం అలా స్కాన్ చేయడం వల్ల ఏమవుతుంది, ఫ్లిక్కర్ ఎఫెక్ట్ ని అవాయిడ్ చేయగలుగుతున్నాం. ఓకే, అండ్ ఆల్సో ఇట్ కన్సర్వ్స్ ద బ్యాండ్ విడ్త్. నెక్స్ట్ కమింగ్ టు ద differences between progressive and interlaced scanning. In progressive scanning, all the lines are scanned at a line by line, that is sequentially scanned. But coming to the interlaced, all the lines are scanned in two steps, that is that means odd lines will be scanned at one field and even lines will be scanned in the next field. Okay. So, in progressive, all the lines are scanned sequentially one by one. Here, the lines are scanned alternatively. Next, the lines are not divided into groups or fields. In interlaced scanning, the lines are divided into two groups. Next, coming to the progressive, the field frequency and the frame frequency are the same. Coming to here, the frame frequency is twice that of the frame frequency. Here the field frequency is double of the frame frequency, because here we are dividing a frame into two fields. Next, the frame frequency. The frame frequency in progressive scanning is 25 Hz. Coming to here, the field frequency is 50 Hz, that is 2 into frame frequency. Next, in progressive scanning, flicker problem will exist but can be avoided with increasing of the bandwidth. But here the flicker problem will be avoided with saving the bandwidth. Thank you. So once see all the definitions and characteristics and the different types of scannings. This is the first difference between progressive and interlaced scanning. And second difference, you.